Okay, this is a continuation of the analyzing data because Nearpod was acting up on me. So we're going to continue looking at analyzing data, in this case, the distribution of the data. So we're going to just ignore this part because we did enough review with that on the previous video. And the first thing we need to do is find the median of this data, and it happens to be 29. To figure out the distribution, we want to see if our data is spread out more towards the minimum, 27, or towards the maximum of 31. In this case, you can see that the distance is just 2 in both directions. So we call the distribution of this data symmetrical. When the distribution of the data is symmetrical, the better measure of center is actually the mean. One more example, again, we're just going to focus on the median and the distribution of the data. So looking at this data, the median of this data is going to be at 22. And again, it would take a little time to do that, but for sake of time, okay, we would list our data out and find the middle. And now we're going to look at the distribution. Is our data stretched more out towards the maximum here or towards the minimum? And it's very clear to see it's stretched out more towards the minimum. That outlier is pulling our median down. So this data is skewed to the left, and our median would be a better way to describe the data. All right, and the last thing we want to look at is a review of box and whisker plots. So box and whisker plots is when we take the data and we separate it into 4 parts. We break it in half with the median, then break the lower half of the data in half with a lower quartile, and the upper half of the data in half with an upper quartile, breaking it into 4 equal parts, each worth 25%. We put a box around the middle part and call that our interquartile range. So if you wanted to get the interquartile range, we would subtract the upper and the lower quartiles. So here's an example of one for us to look at. Just looking at the box and whisker plot and getting information off of it, our median of the data is right here in the middle, which is a 95. The lower quartile would be right here at an 85, lower quartile. The upper quartile is right up here at 100. The extremes are our minimum and maximum. So our lower extreme is at a 70 and our upper extreme is at a 120. The interquartile range is inside of the box, the difference between the upper and the lower quartiles, and 100 minus 85 is 15. To find the distribution of the data, it's just like we did on the other problems. From the median, is it stretched out more to the left or to the right? And this one actually happens to be symmetrical. Its distance from the median to the lower extreme and upper extreme are exactly the same. Therefore, the data is symmetrical, and our mean would be the best way to describe the data. Let's keep in mind that box and whisker plots divide our data into 4 parts and quadrants, and each is worth 25%. That way, when we're describing our data, we can use percentages. Here's an example. What percent of people are over the age of 13? So here's our 13, and over the age is going to be 3 sections. If each section is worth 25%, there are 75% of the people at this concert that are over 13. The next question asks us, what percent of people are between 12 and 18? So I have a 12 here and an 18. Between 12 and 18, I have 2 sections. Each are worth 25%. So that would be 50% of the people are between those ages. And then lastly, what percent of the people are under 25? 25 is right here. Under would be all of it, all 4 sections, which is 100%. And that concludes our review on data analysis.